I'm Todd Anslinger with Chevron. Today I'm going to try to move around a little bit here. Talked about IoT solution enablement at the foundational level. So I'm going to give you a kind of a platform view of what we're doing, and as well as some business solutions to hopefully, my goal is that you can take away something that you gave your time to come here instead of taking a nap before going to SeaWorld. So a little bit about me, 20 years with Chevron, owned my own integration business before that. And before that, I worked for Mobil Oil, which kind of dates me a little bit since that was before ExxonMobil. Originally from Indiana, so I went to Purdue, but I've been in Texas longer, so I'm a Texan now. And I sit on customer advisory boards for Rockwell and MQTT Sparkplug Steering Committee and on the ARC Digital Transformation Council Steering Committee. So I want to start first with the level set of why is it IoT instead of IoT? I spend a lot of my time talking business solutions to operators and management, so try to break it down in case there's some of you in the same boat here. So first of all, let's see a raise of hands. Who uses IoT at home? Okay, that's fairly good. That's better than the reaction I normally get. Who has an iPhone or a smartphone? If you have a smartphone, you have been IoT'd. I don't know if that's a verb, but I just made it one. And the reason is, it's changed your work processes. And that's what we're talking about at Chevron, changing work process. So, for instance, on the left there, I used to go every weekend, check the mileage on my vehicles, does it equal 6,000 miles? I'm gonna change oil if it does. All right, now with the new cars, I don't have to do that. It's me when I need to change oil, right? So I don't have to waste my time going out there and being a manual SCADA person is what I call it. And it gives me a dashboard. Hey, you got one tire that's low there, you might want to look at it. All right, so that's IoT, that's consumer. On the industrial side, really to Chevron, and I'm going to get into our definition of IIoT, but the industrial side is we're using transmitters that are hazardous area classified that you can't use in a beer cooler at 7-Eleven. All right, so we can translate that thing that you do at home to natural gas compressors. So, growing up out in the field, natural gas compressors, you do a PM every 90 days. You change oil, change a handful of valves, right? Just because you stay out of trouble doing it every 90 days. Well, now we can put these hazardous area classified acoustic transmitters and oil viscosity transmitters, and it will tell you when you actually need to PM your compressor. So, and what we're finding is, maybe it's more like once a year instead of 4 times a year, so you can save your scheduled downtime based on that. And just like I do at home, if I get the notification on Tuesday, I set me an alarm on Saturday to change my oil. Same thing. Let's set this for next week to do a PM on that compressor. So what is Chevron's definition of IoT? Now I'm going to weave in the IT-OT convergence here as we do this. So because Chevron, our definition of IoT is not the same as a lot of people's. Some people say if you have a wireless device, that's an IoT device. That's not the case with us. If you look at that red box, that line is drawing an IoT device is something that goes straight from the field to the cloud and does not touch the Chevron network, doesn't touch the PCN, doesn't touch the DMZ, doesn't touch the business LAN, does not touch the Chevron network. Well, why is that? Well, first of all, I need to point out this is not for closed loop process control devices. All right, I grew up in the PCN. My PCN cohorts would get upset and saying, you're trying to replace the PCN. No, we're not. These are things that it's not a level transmitter that's going to change a pump speed, open and close a valve, have a critical shutdown. These are things that change work processes for operators, for maintenance and inspection people, a sensor they can put out in the field, get some insights from the data they can see in the cloud, even tell them, hey, you need to look at this. That's what I'm talking about here. So it's not process control. But, so since it doesn't touch the Chevron network, that means it's more secure. If someone hacks that, they can't shut down the Colonial Pipeline, for instance. All right, so and you can see if you count the number of arrows, integration points, you can see quickly the number of integration points way less. If that was a cellular device up top, it would be turn on the button, go in the cloud, put in a PIN number, it's there in minutes, versus creating an MOC on the bottom, and then running conduit, pulling wire, all those arrows to get to the cloud just to do analytics. Big time and money saver if you're not using closed loop process control. Reliability is another one. So we know that we don't control that cellular connection or whatever it might be. So if that goes down, okay, we just operate how we used to until we get that connection back up. The other thing is, from a reliability standpoint, is you're not going into the PLC to add that transmitter into the PLC. So therefore, you can't go from remote run to remote program and accidentally turn your plant off, which I may have done before. So you take that factor out of it. And but now, so I have this, again, I talk to operators and management. So this over here, this little IoT hub, that looks so nice. It's one box. That must be easy. No, it's not. That's where the collaboration comes into play. So we have our instrumentation and control engineers qualifying the IoT sensors, connecting it to the cloud. So our IoT platform team ingests the data, gives it to our time series data store people that contextualize the data and puts it where it needs to be so that the operations people or asset performance people, which I'm in, can create the dashboard to help give the operator insights and help them do their job more efficiently. So that's really where the IT-OT convergence is. We're working as a team and teams to complete solutions that will give us value in the field. And if you want to see that IoT hub box exploded, go back and watch David Barrett's presentation from a couple days ago from Chevron. So now I want to look quickly about potential large enterprise versus small operator cloud strategies. So if you've ever tried to sell your end-to-end cloud strategy from Chevron and you've gotten crickets, this is probably why. So I'll help explain a little bit why, and maybe to give you some ideas of how to sell to Chevron. So being a large enterprise, we have the cloud capabilities of people that know how to connect the cloud components in the cloud. We can do that, whereas small companies may not know how to do that, may not want to do that. They push that off to a third party. All right, the other thing is our data. We want to keep control of our data. So we have data, it's not only IoT, it's data, it's not only business data, it's the process control network data coming up from our process historian. We want to keep that in our cloud. We're not keen on pushing that out to a third party and to do some analytics over there, because even if this is one of the things to make it cryptic, even if it's the Chevron Porta-John level number 5, if someone hacks that third party, they publicize that they hacked Chevron because they saw a Chevron tag name, right? So that's why we try to avoid that. And plus we have the data scientists in-house that can do all the data science for us, whereas a small operator may not. Maybe they want someone else to do data science. So that's a little explanation there. Third parties often have subscription costs. And if me being in the Chevron Technology Center and supporting 43 business units around the world, if I go to Australia and say, hey, you need to do this, it's a great solution. By the way, it's going to increase your OpEx by $2 million a year. They're going to say, sorry, Chevron Technology Center, we don't want that. So again, and we're thinking of the customer. All right, so the other thing is the customer. That's one thing from a customer cost standpoint, our customer. The other thing is from an interface standpoint. So if we put our tanks in one cloud, we put our pumps in another cloud, vibration, we do our compressors in another cloud, they got to learn 10 different interfaces to do their whole job. That doesn't make sense. We want them to learn one interface that we've built in our Chevron system. And also, by the way, my guys, I don't want them to have to go to 10 different clouds just to support all those IoT devices. We want to have one place to do it in our IoT hub and way easier to manage. And then, of course, we want to use open systems. Anything that can go into our IoT hub, that saves us time and money. We don't want to use vendor A's flavor of a device or a gateway that has to go to vendor A's cloud because they may not do everything that we want to do from a sensor standpoint. So hopefully that gives you some ideas of why it's been hard to get traction if you are a end-to-end cloud provider, and hopefully helps you sell to us if you have good ideas. Because the other thing I didn't say is your analytics may be great. We'll probably want you to do them in our cloud, and we can still get value from that, and we can still work together. So kind of to wrap this foundational piece up, how is Chevron enabling IoT at the foundation level? So we're standardizing on qualified sensors and gateways. We have a dashboard that people can look at and see what are we testing, what's approved, what's denied, why, how much things cost. Ingesting data directly into our IoT hub and event hubs, directly into ours. Ingesting data from third parties when required. And managing our devices from one place, IoT hub, and that equals scalability to the enterprise. Because really, when we look at a solution, we're not thinking, oh, that's going to help this plant do 10 things. No, we're thinking enterprise, global. We're going to have millions of devices, across the globe. So that's why all these things are equaling the scalability to our enterprise. All right, so now for the thing that you probably were here the most to see is what are we doing in IoT to bring value to Chevron. So firstly, greenhouse gas monitoring. We're putting cameras on flare stacks and notifying people when they see a flare so we can take care of the upset sooner. All right, we're doing methane management with vibration transmitters, acoustic transmitters, or cameras, or volatile organic compounds, putting those sensors along fence lines and knowing the wind direction, concentration speed, or wind direction speed, and pinpointing, saying, hey, go look in this 10-meter area, the leak is likely there. Again, stopping our leaks within a half hour versus it could be weeks for people to go, again with work process, going around with the wand, seeing, okay, where's their benzene being leaking here? So it's telling us and it's helping us to cut down on those releases. And then carbon capture, we're injecting CO2 in Australia and Canada, and we're using IoT sensors to monitor those pressures to make sure that they're not getting out of what they're being injected in. Heat exchanger monitoring, we were finding that we put heat exchangers on a 5-year cycle. We break them open every turnaround. We were opening heat exchangers to clean them, and they were already clean. So we've just wasted time and money opening them up. So we're putting temperature transmitters on the inlet and outlet of the tubing and the shell and trying to predict when it's foul and say, okay, look at it 18 months from now. Look at it 36 months from now. Or, hey, you're gonna have a problem in 6 months, you better switch it. We don't wanna have to turn down production because we got something that's fouled up. Asset performance, electrical assets. We're doing peak load management because when you get billed by electricity, at least industrial companies, you get billed on that peak. So if you can cut that peak down, you can save some money, and that's just one peak in the month. Or looking at some of the frequencies that tell you what your prime movers are doing with some of your motors. Automated performance monitoring, that's really vibration monitoring. Here's where we see hundreds of thousands of devices that we can use to monitor some of those, not the prime movers, the smaller stuff. So, targeting $500 to $600 for a vibration transmitter that can, again, say, hey, you're gonna need to do a PM on this in, 3 or 4 months. So to help us with that and not have to go out there and manually go do it every quarter or every year. Reduce site visits frequencies. So this is where we're using non-SCADA devices on tanks, casing pressures, because they're regulated by the Railroad Commission, injection pressures, so we don't exceed our injection permit. Normally unattended facilities, you probably heard that from a few Chevron people today. Really looking at the IO list on a greenfield and saying, does that need to be there for closed loop process control? Great, add a PLC card for it. If you're looking at it once a day, once a week, once a month, that can be an IoT device and save us on some design and installation. Mixed reality, there's been enough said about HoloLens that Chevron uses there. And so the last thing here, why advance IoT capabilities? So first one is increase personal safety. We don't want to make the operator go out there to the field just to write down a number, and that's quite frankly boring. I've ridden with them, a lot of operators, and we want to give them value-added stuff to do, right? And we want to keep them out of harm's way of H2S just to go write down a number. Business value, cost avoidance, that goes back to using an IoT device instead of something in the PCN. It also goes back to, I would love to talk about well monitoring, but I don't have time. So if you see me later, I'll be glad to talk about that. Drive efficiency at scale. Again, we're thinking, what does this look like to the enterprise? We're going to be doing hundreds of thousands, millions of devices. So we have to think about the scalability factor. Reducing carbon intensity, we'd already talked about that. Attract and retain talent. This is one of my favorite stories. We had an intern data scientist that came into our group, and she took the drone data. Drones flew up and took pictures and videos of insulators on electrical lines, which we're supposed to do that once a year. Well, she did the analytics that looked at the insulator and saw what percentage of rust was on that insulator and told them what they need, how many insulators they need to replace and exactly where they are. And at the end of her presentation that summer, she's like, I didn't know that I could do something so impactful in an oil and gas company. You know, she was thinking she was going to work for Google or AWS. But so this is the kind of people we have to show them what they can do and the impact they can have, even as a data scientist, which goes back to the whole reason of this thing, IT/OT convergence. That took her, an IT data scientist, working with the operations people, with the maintenance reliability people to come up with this solution. So that's how we're doing IT/OT convergence.